Here we are going to balance redox equations. And so this is a recipe to help you be able to balance a redox equation, whether it's in a neutral solution, an acidic solution, or a basic solution. So all you need to do is follow this recipe. Step 1 is write as much of the overall unbalanced equation as possible. And when you're doing this, you're going to remove or omit any spectator ions that might be present. Step 2, you're going to construct an unbalanced oxidation and reduction half reactions. These are usually incomplete as well as unbalanced, so don't worry about balancing these half reactions just yet. You're going to show the complete formulas for any polyatomic ions and molecules. Tabulate the oxidation states that can help you identify the oxidation and reduction half reactions if you're unsure which one is which. Third step is balance by inspection all the elements in each half reaction except hydrogen and oxygen. We're going to save those for later. Then you have to decide, okay, is the reaction acidic, neutral, or basic? Depending on what type of solution your reaction is being held in, you're going to add the H plus ion, water, H2O, or the hydroxide ion, OH minus, to balance out the hydrogens and oxygens in each half reaction. Step 4, you're going to balance the charge in each half reaction by adding electrons as products or reactants. Then you're going to balance the electron transfer by multiplying the balanced half reactions by appropriate integers, because we always have to have the electrons balanced out as well. Step 6 is you're going to add the half reactions together, and when you do that, you're going to eliminate any common terms. You're going to add the common species that appear on the same side of the equation, and then cancel equal amounts of the common species that appear on the opposite sides of the equation in equal amounts. So the electrons must always cancel whenever you're combining the half reactions. The last step, and the most important step, which most people forget to do, is check your work. Make sure that the elements are balanced, that you have mass balance, meaning that we have the same number of atoms on each side of the arrow, so in the reactants and the products, and that you have a charge balance on both sides of the equation. How do we distinguish acidic, neutral, and basic reactions when we're balancing? If it's an acidic or neutral solution, you're going to first balance the oxygens by adding water to the side needing the oxygen, and then you're going to balance the hydrogen by adding H pluses to the side needing the hydrogen. If it's a basic solution, you're going to follow the same steps that you did in the acidic solution, except you have to remember that a basic solution should not have any H pluses. There should only be OH minuses. So first balance out the oxygens by adding water to the side needing the oxygen. Then to balance out the hydrogens, we're going to add H pluses to balance out the hydrogens. Then for every H plus you have, you're going to add an OH minus on both sides of the equation. You're going to add it to the reactant side and the product side. And so what happens is that H plus and the OH minus will combine to make water, and you end up with OH minuses on the other side. And that is how you balance out the oxygens and hydrogen. In every case, whenever you are done with balancing your redox equations, you need to make sure that all the balanced equations must be mass balanced and charge balanced. Now let's do some examples. The first example we're going to do is a reaction that's in an acidic solution. So the very first thing we need to do whenever we balance a redox reaction is first assign oxidation numbers to all the elements and determine what is being reduced and what is being oxidized. So Fe2+, that's already assigned, that's a 2+. The oxygen is going to be a -2. We have 4 of those, so it's a -8. This whole thing is going to be a -7, so that means its manganese is a +7. And so here we have the iron 2+ goes to an iron 3+, and the manganese goes from a +7 to a 2+. So here we're increasing in oxidation numbers. Here we are decreasing. And so this is reduction, and this is oxidation. Now that we know what is being reduced and what is being oxidized, we can write our half reaction. So our half reactions are going to be Fe2+ goes to Fe3+. That's our oxidation half reaction. And then our reduction half reaction is going to be the MnO4- goes to Mn2+. Now that we have our half reactions written, we now need to do a mass balance. Make sure our elements are all balanced. We're going to ignore hydrogen and oxygen on both of these right now. So first, in the first one, ions are balanced. We have 1 iron on both sides, so we don't have to worry about that. And in the second one, the manganeses are balanced, so we don't have to worry about the iron or the manganese. Now let's worry about hydrogen and oxygen. Well, we don't have any hydrogen and oxygen in the first one. We do have oxygen in the second one. So we have 4 oxygens on the left-hand side. So to balance out the oxygen, we have to add water. So since we have 4 oxygens, we need to get 4 oxygens on the product side. So we're going to add 4 waters over here. Now, why can we add water? Well, this reaction is being done in an aqueous solution. This is an acidic solution, which means that there is water present. So we're not breaking any rules by adding H2Os here. Okay, so now that we added 4 waters, our oxygens are balanced, but we introduced hydrogen by adding the water. We added 8 hydrogens, so that means we need to have 8 hydrogens on the left-hand side. Since it's an acidic solution, we're just going to add 8 H+. So here, ions are balanced. That's good. That's done. Second one, we have 8 hydrogens, a manganese, 4 oxygens, 4 oxygens. We are now mass balanced. However, we are not charge balanced. And that is the key difference between normal equations and redox reactions. We always have to balance out the charge. So how do we balance out the charge? We do that by adding electrons. Here we're going from a 2+ to a 3+. We need to balance out that charge by adding an electron. So we're going to add 1 electron to that half reaction. When we do that, our charge is now balanced. 2+, 3+ minus 1 gives us 2+. So our charges are balanced on both sides. What about for this one? We have a +8 and a -1. So that gives us a +7 on the reactant side. And then on the product side, we have a +2 from that manganese. Water is neutral. So to balance out this charge, we have to add 5 electrons on the reactant side. Now that we've balanced out the charge here and we balanced out the charge here, we need to combine these 2 half reactions. So before we combine them, we need to make sure that our electrons are equal. Right now we have 1 electron here and 5 electrons here. So we need to balance out the electrons. And we do that by multiplying this whole reaction by 5. When we do that, we end up with 5 3+, or 5 2+, 5 3+, and 5 electrons. And so when we add these 2 half reactions now, the 5 electrons will cancel. So let's go ahead and do that. And we're going to just combine all the reactants. And we can go ahead and cancel out the 5 electrons because they're on both the reactants and the products. So we have 5 Fe2+, we have 8 H+, and MnO4-. That's everything on the reactant side. Now what about the product side? This 5 goes over here to a 5 Fe2+, 3 plus, we have an Mn2 plus, and 4 waters. Now what we need to do is, do we have anything that's the same on both sides? And we do not. We have Fe2 pluses, there's nothing over here. We have H pluses and MnO4s minuses over here. We don't have anything over here that's equal. So both sides are all different. There's no common species on both the reactants and the product side. So we don't need to fix this anymore. So this ends up being a balanced equation, but again, we always want to check our work. Make sure that we are mass balanced and charge balanced. So let's check out the mass balance. We have 5 irons, 8 hydrogens, 1 manganese, 4 oxygens, 4 oxygens. We're mass balanced. Now what about charge balance? 5 times 2 plus is a plus 10, plus 8 minus 1 for the reactant. So that gives us a total of 17. And then over here we have 5 times 3 plus, which is plus 15, plus 2 gives us 17. So our charge is now balanced. So our final balanced equation is 5 Fe2 pluses plus 8 H pluses plus MnO4 minus goes to 5 Fe3 pluses, Mn2 plus 4 waters. Now let's do a reaction that's in a basic solution. So again, we need to first write down the oxidation numbers for all species that are present. So oxygen is a -2. We have 2 of those, so that's a -4. Chromium ends up being a +4. Oxygen -2, so this chlorine ends up being a +1. -2 gives us a -8 because we have 4 of those. This whole thing is a 2-. That means this chromium is a +6. That chlorine is a -1. So our half reactions are going to be the chlorine and the chromium are what changed. And so these are our half reactions. So we'll start off with CrO2 goes to CrO4. And let's not forget our charges here. 2- and a minus. And then we have a ClO- goes to a Cl-. Okay, now that we've balanced that, or we have our half reactions, we need to now balance out the masses for each one. So we'll start off with the chromiums. Chromiums are good, and chlorines are good. So all other elements are balanced. The only thing different now is the oxygens. We have 4 oxygens and 2 oxygens, so we need to add 2 oxygens, and the way we do that is by adding water. So H2O, and we need to add 2 of those. So now we have 4 oxygens and 4 oxygens. Now we need to balance out the hydrogens. So the way we do that is we have 4 hydrogens, so we need to add 4 H pluses on this side. But remember, this is a basic solution. Since it's basic, we're not allowed to have any H pluses. So we need to balance out all the H pluses with OH minuses. So since we have 4 hydrogens over here, we need to balance that out with 4 OH minuses. Since we did it here, we also have to do it on this side. Whatever you do on one side, you have to do on the other, just like you do in an algebra class. Alright, now that that's balanced, our masses should all be balanced now. So let's just double check. 4 oxygens, 2, so 4 plus 2 is 6, 8. 4 and 4 is 8. 4 hydrogens is 8 hydrogens. 4 and 4, so we're good there. And 1 chromium and 1 chromium. So now we are mass balanced. Let's mass balance this half reaction now. Chlorines are okay. We just have to add the oxygen. So we do that by adding a water. Now that we added a water, we have some hydrogens on this side. We need hydrogens on this side. 2 hydrogens means we add 2 H pluses. Again, it's a basic solution. We're not allowed to have H plus, so we have to cancel that H plus with 2 OH minuses. since we added two OHs over here, we need to add two OHs over here to make sure that we haven't added any extra oxygens or hydrogens. Now everything should be balanced, so let's just double check this one real quick. 2 oxygens, 1, so that's 3 oxygens. 1, 2 is 3. 2 and 2 is 4 hydrogens. 2 and 2 is 4 hydrogens. And we have 1 chlorine and 1 chlorine. So now everything is mass balanced. Once it's mass balanced, you now need to charge balance. So let's check the charge on this. Let's first do this one. We have a -4 here, and then a -1, so that gives us a total of -5. And then over here we have a -2 and a +4, and then a -4, that gives us a -2. So -5, -2. So we need a total of 3 electrons over here to balance out the charge. Now let's balance out the charge on the second one. We have a -2 and a +2 and a -1. That gives us a total of a -1 on the left-hand side. On the right-hand side, we have a -1 and a -2. That gives us a -3. And so to balance out this charge, we need to add 2 electrons on this side. Now, remember, for every half reaction, if you add electrons on the products, on this half reaction, you have to have electrons on the reactant. You can't have both of them on the reactants or both on products. They have to be on opposite ends. So now that we have 2 electrons and 3 electrons, we need to balance out those. Common multiple between 2 and 3 is 6. So we're going to multiply this by 3 and this by 2. And so let me rewrite this. We have 8 OH minus plus 4 H2O plus 2 CrO2 minus goes to 2 CrO4 2 minus plus 8 H plus 8 OH minus plus 6 electrons. Now do the same thing with this one. We need to multiply everything by 3. And so this is 6 electrons plus 6 OH minus plus 6 H plus 3 ClO minus goes to 3 Cl minus plus 3 H2Os plus 6 OH minus. Now we have the same number of electrons. We can cancel those out because we don't want any electrons left over. And now what we do is we combine H's and OH's and everything to make water, and everything in the reactants we add together, and everything in the products we add together, and then we can then cancel out on both sides. So let's do this real quick. This right here ends up being 6 waters, so we can just rewrite that as 6 H2Os. And we have 4 waters here, so let's go ahead and bring down to 8 hydroxides. So 8 OH minuses plus 10 water. And then we have 2 CrO2 minus plus 3 ClO minus. So that's everything on the reactant side. Now let's do the product side. So we have 2 CrO4 2 minus. This right here ends up turning into 8 waters. And we already have 3 waters here, so 8 plus 3 gives us 11. So that is 11 waters. And we have 3 chlorides and 6 OH minus. Okay, now we can clean this up just a little bit more. Let me scoot this up a little bit. All right. So notice we have 8 OHs over here and we have 6 in the products. So this will cancel this out to give us 2 OH minuses. We have 10 waters here and 11 waters here, so those all go away, leaving just 1 H2O. And then everything is left alone. So what we're left with is 2 OH minus plus 2 CrO2 minus plus 3 ClO minus goes to 2 CrO4 2 minus plus a water plus 3 chlorides. Okay, now what we need to do is check to make sure that everything is mass balanced and charge balanced. So let's first check our masses. Let's first check out oxygen. We have 2 plus 4 plus 3, so that's 9 oxygens, 8 non-oxygens, so our oxygens are good. What about hydrogens? We have 2 hydrogens and 2 hydrogens, 2 chromiums, 2 chromiums, 3 chlorines, 3 chlorines. So we are now mass balanced. What about charge balance? So 2 or minus 2, and then a minus 3, so that gives us a total of minus 7. Over here we have a minus 4, minus 3 gives us minus 7, so we are charge balanced as well. So the balance reaction is this right here.